All right, continuing with our next topic B with lesson 7, we're going to be applying our knowledge of unit rates and ratios and proportional relationships to how is a unit rate as the constant of proportionality. So again, you'll need your lesson worksheet and your math journal available, but we're going to be starting with your lesson worksheet and example 1. So here's a copy of the original question. Wildlife conservationists are concerned that the deer population might not be constant across a national forest. So scientists found that there were 144 deer in a 16 square mile area forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area, and yet a third conservation counted 216 deer in a 24 square mile plot of forest. So, do conservationists need to be worried? So again, on your lesson worksheet, why does it matter if the deer population is not constant in a certain area of the national forest? Well, any theory is acceptable, but it might mean that more deer are getting killed off in other areas, or that they will continue to die off, or maybe there's something going on with the habitat. But any theory is acceptable. So we're going to make a table of ratios and their unit rate equivalents. So what is the population density of deer per square mile? So our relationship is deer per square mile. And this is what our table will look like. So we have square miles is 16, and the number of deer in that square mile, or in those 16 square miles, is 144. So again, we are looking at miles. We're picking the square mile, and that becomes our independent variable, and so our dependent variable is the number of deer. We can't choose a random number of deer once we pick a square mile. So square miles is independent, and the number of deer is dependent on the square miles that we pick. So that's when we set it up, it's 144 deer divided by 16 square miles, and that gives us 9. The same thing with 117 divided by 13 and 216 divided by 24, and you'll see that we get a constant unit rate of 9. So when we find the number of deer per 1 square mile, what is this called? This is called the unit rate. And again, you can be summarizing this in your math journal, but a lot of this is just repetition and review. When we look at the relationship between square miles and the number of deer in the table, how do we know if the relationship is proportional? Well, the square miles is always multiplied by the same value. In this case, it is 9. So we're going to call this constant or same value the constant of proportionality, because we know what constant means. That means the same. And proportionality means that it is the same value between two values. The relationship between two values is always the same. So the deer per square mile is 9, and the constant of proportionality is 9. Is that a coincidence, or will that always be the case, that the unit rate and the constant of proportionality are always the same? And we're going to come back to this question later. So we could add the unit rate to the table so that we have 1 square mile in the first column and 9 in the second column. So you're going to add this to the table. Go ahead and add this column to the table. So does that help to guide your decision about the relationship between the unit rate and the constant of proportionality? Or we're calling it COP. Well, we'll see if your hypothesis holds true as we move through more examples. So, on your lesson worksheet, let's go back to that. The unit rate of deer per square mile is 9. The constant of proportionality is k equals 9. Because again, we did our y, which is the number of deer, divided by our x, which is the number of square miles, and that gives us our constant, which is 9. So the meaning of constant of proportionality in this problem is that there are 9 deer for every 1 square mile of forest. So we use the unit rate of deer per square mile to determine how many deer there are for every 207 square miles. So we would just take 9 times 207 square miles, and that's going to give us 1,863 deer. So use the unit rate to determine the number of square miles in which you would find 486 deer. Well, now it becomes a division problem. We take 486 deer. We know that it's 9 deer per square mile, and so when we divide 486 divided by 9, we get 54 miles, or square miles. So do conservationists need to be worried? Be sure to support your answer with mathematical reasoning about rate and unit rate, and you're going to write this answer as part of Section D on your lesson worksheet. I'm not going to give you an answer for this. You need to take the information that we've talked about and come up with your own conclusion. When you are done with that, go ahead and continue the video. Alright, so you should have a conclusion at Part D of your own words and examples. So on your lesson worksheet, go ahead just to practice our repetition. Highlight in the vocabulary, or highlight the vocabulary in the box. And in your math journal, you're going to write the vocabulary words and definitions and summarize the description of constant of proportionality. Go ahead and pause the video and take care of this activity, and then go ahead and continue when you are done. Alright, so you should have highlighted the vocabulary in the box and written down the important vocabulary words and definitions and summarized the description of constant of proportionality. Remember that in the example with the deer population, we are looking for deer per square mile, so the number of square miles could be defined as X, and the number of deer could be defined as Y. So the unit rate in deer per square mile is 144 over 16, or 9. So the constant of proportionality, K, is 9. So the meaning in the context of example 1 is there are 9 deer for every 1 square mile of forest. So how are the constant of proportionality and the unit rate alike? Well, they are both the same. They both represent the same number. That is the value of the ratio of Y to X, or in this case, deer to square miles. Now it's your turn to do example 2 and 3 on your lesson worksheet. Go ahead and pause the video, try examples 2 and 3, and then check your answers afterwards. Alright, if you are to this point, you should have done 2 and 3, and here are the answers. So check the table against yours. Again, the number of cookie sheets and the number of cookies baked is 2 to 36, which means the ratio is, or to find the unit rate is 36 divided by 2, which is 18. And then to do 4 to 72 and 10 to 180 and 16 to 288 is the same, 18. So the unit rate is 18, which means the constant of proportionality is 18. And what does that mean in the context of this problem? That there are 18 cookies per 1 sheet. It's really important that you write it in a sentence, because now you are labeling each part of the problem. So make sure you pay attention to that. Part B, if it takes 2 hours to bake 8 sheets of cookies and they begin at 4 p.m., then when will they finish? So if they have 96 students and they're going to eat 3 cookies each, that's a total of 288 cookies. And if we know that it's 18 cookies per sheet, we're going to need 16 sheets of cookies. And if it takes 2 hours to bake 8 sheets, then it's going to take 4 hours to bake 16 sheets of cookies, and so they will finish baking at 8 p.m. Right, for example 3, the cooking class, go ahead and compare your answers to A, B, and C. And again, if you have any questions with either of these two examples, make sure you write down your question on a sticky note or as a thought bubble in your notes and highlight it so that you can be sure to ask in class. All right, so to summarize, what is another name for the constant that relates the measures of two quantities? It is called the constant of proportionality. And how is the constant of proportionality related to the unit rate? They are the same. All right, we will see you in class.